So do you guys remember the word problems that we did when we did the trig graphs? We did the one about the Ferris wheel going up and down. Do you remember that? Okay. We did the one, there was one that was like about a windmill. Then we did the temperatures going up and down in certain places. Do you remember those? Okay. We're gonna start by doing one of those again as like a jumping off point for these equations. So it takes 8 seconds for you to take one breath in and out, okay? When your lungs are full, they hold 4 liters of air. We're gonna pretend that when you breathe out, your lungs get completely empty and it goes down to 0. I don't think that's actually true, because if you're alive, I think you, like, can anyone verify that? Like, you hold some sort of capacity in your lungs. Okay, but we're gonna pretend it's 0, okay? So that the math works out nice. So when your lungs are empty, it's 0. When they're full, it's 4 liters. Where's the center of that? 2. It wasn't a trick question. Are you all awake out there? 0 and 4, halfway between them. So we're gonna start at 2. That's our center. It's gonna go up to 4. It's gonna come back to 2. It's gonna go down to 0, and then it's gonna come back to 2. Do you remember the wave, the sine function? That's a wave. Okay. Now, before I start putting more points in here, though, you have to think about the period of the function. It's gonna take 8 seconds to do 1 breath. So when you get to 8 seconds, that should put you back where you started. I'm going to draw in like a dotted line here at 2 for reference so that I can kind of see what I'm doing so my graph doesn't get all wonky. So at 8 seconds, you're going to end up back where you started. Okay. What's halfway between 0 and 8? 4. So at 4, you're going to also be in the center. What's halfway between 0 and 4? See how I made all the numbers nice and even for you? So at 2, where am I going to put a point? 4. It's going to be 4 liters of air in your lung. Your lungs hold a lot of air. So it starts at 2, goes up to 4, comes back to 2. And then where am I going to put the point down at 0? So, good. Okay, cool. I woke you guys up. Could you continue that pattern for 1 more breath? Like, just keep it going. So like at 10, we're going to be up here at 4 liters. And this won't look perfect because I don't have, lines on here. 12, you're going to be back in the center. 14, you'll be at 0. And then 16, you're going to be back in the center. And when you connect it, just make an attempt to get it to be a nice smooth curve. Like, again, not here to grade your art skills, but try and make it look nice. Bless you. And then obviously it would keep going. We don't put arrows on the end because it's going to not go one direction forever. It's going to keep on waving. And hopefully you're going to keep on breathing. So we're going to use that to answer the questions on the back. So go ahead and flip it over. We've done this before. Okay. We make our table. It was from 0 to 8 seconds. And we said halfway in between was 4. And then in between these, you get 2 and 6. You can flip it back if you want, but I mean, like, hey guys, where did we start? It was 2, and then it goes up to 4, back to 2, down to 0, back to 2. It's a wave. I made all the numbers nice and even for you. I was trying to make it a nice problem. So we're going to use that to put it all together and write an equation. Oh, we did these on delta math. Remember where you played with it and like stretched and shrunk it and moved it and reflected it? It was cool. And then like you saw it match up. And okay, we're going to do that, except it's not on the computer. So let's start with, where's the center? That's how much you want to move it up. Where was that center line? 2. And what's your amplitude? How far from that center line do you go in each direction? 2. So like this distance right here is also 2. I don't know how to flip over a piece of paper. All right, now the way you get the B value, do you remember it was A, B, C, D for all of that stuff? 2 pi over B is going to give you the period of the function, which, what's the period of this function? How many seconds for 1 breath? 8. Good. And then we're going to solve that. You would multiply B to the other side. So multiply the B over, and then you would divide both sides by 8. So how does that reduce? That's what we want to go on this blank right here. Pi over 4. Good. Perfect. That was kind of like the bonus question on that test. Remember, how do you like build an equation? And then these were the kind of questions I asked you on your test, like about what, like when is the temperature, whatever in that city. So when, looking for a time, when do your lungs hold 0 liters? So flip back over, look along 0. When do your lungs hold 0 liters? 6, 14. How would you get the next one? Because it's going to keep going. Add 8. Okay. So do you remember you take the first thing? So 6 seconds. And then plus 8n. Or I guess I could have written seconds at the end. It doesn't really matter, but every 8 seconds after that is when you're going to have 0 liters in your lungs. I'm going to skip this one and go to the next one. Let's do, when do your lungs hold 4 liters? All right, so when's the first time your lungs hold 4 liters? 2 seconds, and then the next one is 10 seconds, and then the next one would be, keep adding 8 every time, so like 18. All right, so you're going to put 2 seconds plus 8n. So let's go back and grab that one. When do your lungs hold 2 liters of air? Well, what's the first one? 0 seconds. But then the next one is 4, and then 8, 12, 16. So we're going to start with 0 seconds, but it's not going to be plus 8n. It's going to be plus 4. Why is that one happening more often? The one in the middle, okay? And then here is our jumping off point. This is like what I was leading up to. You've done all of that before. This is going to be the new thing. When do your lungs hold 1 liter of air? You see how if you draw lines through at 1, it doesn't intersect at nice whole numbers? That's the new thing I'm teaching you, is how to find those answers. You may have noticed back on your test, I only asked you about the ones that showed up in the table. If it didn't show up in the table, I just didn't ask you about it because I hadn't taught you how to do it. Well, today is that day. So what I like to do is circle back to this question as a warm-up for next class. So don't lose this. This is going to be your warm-up question next class. I'm going to teach you how to do this, and then we're going to come back to the breathing question. So that's like the point of that's what I'm getting. So go to your other sheet, and again, we'll do about half of it. We'll do the front page, and I'll give you another little break because I know that this is a lot. All right. You have solved equations before. This is not new. You've done that. All right. The fact that it's trig is new, but you guys know the unit circle. What would you do? Let your instincts kick in. What would you do to start solving this? Subtract over the 1. Good. And then what would you do? Again, like go by instinct. You guys know what to do. What would you do next? Divide by 2. Oh my gosh, 1/2 is on the unit circle, guys. Isn't that crazy? It's going to have to come out to something that's on the unit circle. Otherwise, it won't work. All right. Now we're going to draw our picture, and your picture is, you know, your work. This is sine, and it is negative. There are 2 quadrants where sine is negative. Sine is your y value. Where is your y value negative? Quadrant 3 and 4. Now you don't have to label both of them. You can just do one or the other. I don't care which one, because they're technically the same triangle, just reflected. So it doesn't matter which one. Sine is the y value, so your negative 1/2 goes there. What angle goes across from 1/2? 5 or 6. Now we don't rotate backwards for these. We're just going to rotate forwards. It's not inverse trig. All right. So you're going to get 2 answers. What is your angle in the 3rd quadrant that has a denominator of 6 is basically what you're doing then. So this one's going to be 11 pi over 6. What's this one going to be? 7 pi over 6. So those are your 2 answers. Pretty much it. Let's try it again. We're just going to try it a bunch more times. What would you do? Let your instinct kick in. What would you do to both sides here? To start solving. Yep. Subtract 5. 4 minus 5. Is that what you said? Sorry, I just didn't hear you. 4 minus 5. -1. And then divide by 2. Oh my gosh, 1/2 is on the unit circle. Isn't that crazy? Now this one's cosine. We need quadrants where cosine is negative. Cosine is your x value. So where is your x value negative? Yeah, it's quadrant 2 and 3. You're going to the left. So your x value will be negative in those 2 quadrants. And again, you can just label one or the other. You don't have to do both. But if this is -1/2, that means the other side, square root of 3/2. And what's your angle across from that? pi/3. Good. So you get two answers. You want your answer in quadrant 2 that has a denominator of 3, and your answer in quadrant 3 that has a denominator of 3. So just know your unit circle. What's this one going to be? 2 pi/3. And then this one, 4 pi/3. Hanging in there? You doing okay? You can start to just churn them out once you get good at these, all right? This one, you would add 1 to both sides. And then divide by 2. Now you're not finished yet though. Whenever there's a squared, you have to square root. And whenever you put a square root, you also have to put plus and minus. Perfect. All right, so we're going to get sine of x equals plus and minus. What is your square root of 1? 1. And your square root of 2 is square root of 2 without a calculator. And good, it's going to be plus and minus square root of 2/2, which, oh my gosh, is on the unit circle. If you get stuck and you can't figure it out, pick something that's on the unit circle. So it has to be. Now, whenever it's plus and minus, I actually kind of like that, because what quadrants are you going to be in if it's positive and negative? Yeah, all of them. So you don't have to think about it. It's going to be all of them. And also it looks like a bow tie, which I just think is cute. So I like when it ends up being all of them. And you only have to label one of them because they're all the same triangle. For your square root of 2/2 triangle, what's your angle? pi/4. So you're going to get 4 answers, and you're just going to go around the unit circle and grab all the ones that are fourths. So it'll be pi/4, and what else? 3 pi/4, 5 pi/4, 7 pi/4. I ran into my space for the other one. How much space that one's going to take up. That was not a good thing for me to run into that one. Oh well. Now this, let me see if I still have a formula sheet up here. Shouldn't have taken away from you. My bad. I need one of these formulas for this one. Do you see how it says sine of 2x? You see that 2 in there? So we're going to need this double angle formula. This says A, that paper says X, same thing. But what is sine of 2x going to equal? Yeah, 2 sine x cosine x. You see how I'm just grabbing that from this formula sheet here? Right, which you're allowed to use on a quiz or test. All right, so it's going to be 2 sine of x cosine x is what I'm replacing that with. And you might be like, Ms. Cole, how is that better? Well, we got rid of the 2x. You can't have the 2 inside of there like that. So we got rid of that. Now this next step is going to be algebra. Do you see how both terms have a sign in them? We're going to factor that out. It is a greatest common factor. Do you remember GCF? You're going to factor that out? You okay? Back there? You all right? Are you all right? So you're going to put sine of x, start a parenthesis. What's left when you factor out sine of x? You're just removing it from both of the terms. Yeah, good. 2 cosine x minus 1. Can't write. Do you remember when we factored quadratics and you ended up with like x plus 3, x plus 7 equals 0, and you would set them both equal to 0 and get 2 answers? Remember that? It's the exact same thing here. You're going to set this equal to 0, and you're going to set this equal to 0. So it just became like a 2-part problem. So for this first one, that's not going to be a triangle, that's going to be a circle. You're looking for places on the unit circle where sine is 0. Sine is your y value. There's going to be 2 of them. Looking for words like up, down, left, right. Where is your y value 0? Yeah, left and right. And so this first one is 0 pi. And then what's the one on the left? Pi. Good. All right, and then we're going to do this one. I'm going to combine some steps here just for not having enough space. What would you do first? Add 1, so it'll be a positive 1, and then you would divide by 2. So 1/2, which, oh my gosh, is on the unit circle. We want quadrants where cosine is positive. Cosine is the x part of the point. So that would be to the right. Good. 1 and 4. Cosine is x. So the 1/2 goes there. That means the other side is square root of 3 over 2. And so what's your angle? Pi over 3. And so you get your two answers. First one's pi over 3. What do you get in the fourth quadrant that is a third, something that's over 3? Think about it. Fourth quadrant's hard. You have to go the whole way around almost to get there. Good. 5 pi over 3. If you just count, like, it's going to make sense. You're going to, because I mean, it's not 7/3. Like, you've done this enough that it'll make sense. All right. Maybe we'll do one more and then I'll skip that last one. All right. I realize this looks completely awful, but again, there's only two terms. And what if they both got in them? Do you see how they both have a cosine squared? We're going to factor that out. It's GCF. So you're going to put cosine squared, start a parenthesis. What's left once you take out the cosine squared? Just factoring. Get square root of 3, like the other stuff, right? Square root of 3 cotangent minus 1. Still have a 1 there. And so again, you're going to set this equal to 0 and you're going to set this equal to 0. It becomes a two-part problem. So let's do the first one. To get rid of a squared, you would square root. But guys, what's the square root of 0? 0. So you're looking for places on the unit circle where cosine is 0 and cosine is x. So words like up, down, left, right, where is x going to be 0? Up and down. So what are those two answers? What's the one at the top? Pi over what? Pi over 2, and then this one is 3 pi over 2. I'm going to do the same thing I did on the other one and like combine some steps for the sake of time here. You would add over the 1, so be a positive 1, and then divide by square root of 3. So you're going to get cotangent equals 1 over square root of 3. And you are probably like, hold on a second, that is not on the unit circle. But what did I tell you to do? Like when we set it off to the side, I said to put them both over 2. And now you have stuff that's on the unit circle. It has to work out that way. Like I can't give you an undoable problem, right? So we need quadrants where cotangent is positive. Tangent and cotangent are a little tricky. They're the ones that are across from each other. Everything's positive in quadrant 1. The other place where cotangent is going to be positive is quadrant 3. The reason for that is tangent and cotangent are opposite over adjacent or adjacent over opposite. And if these are both negative, then the negatives are going to cancel out. All right. I usually just remember tangent and cotangent go across from each other. So cotangent is x over y. So 1/2 is the x, square root of 3 over 2 is the y. And so what's your angle? Pi over 3. Perfect. And so what are your two answers? One for each triangle. 4 pi over 3. Again, for the sake of time, I'll fill this one in and put it on there for you. You're going to have to replace the secant squared using one of those Pythagorean identities. I'll write it up there for you. I can tell you guys are fading, so I'll give you another little break and then we'll do a couple of these. I won't need to do every single one of them. I'll just do a few. So all the ones on the other side of the paper said solve for what? So just once around the circle, right? Just go one time around. These ones say solve for all solutions. That means going around and around and around the circle forever and ever and ever. So you're going to have like a plus something n. Other than that, you solve it the exact same way though. So again, I won't do every single one of these because I know you guys are through with me, but let's just do a few. All right, what would you do to start solving this one? Yeah, divide by 2. Again, solving equations is familiar territory. Like I get that the trig part is new, but you know the unit circle and you've solved things before. Then you decide what quadrants you're in. Sine and it's negative. So which quadrants is sine negative in? Sine's y. So where is your y value going to be negative? 3 and 4. It's going to go down. And you don't have to label them both because they're the same triangle, just reflected over. So just label one of them. Negative square root of 3 over 2 is your y value. That means the other side's a half. What's your angle across from square root of 3 over 2? Pi over 3. So we're going to write these one at a time. Let's do the first one. If you rotate into quadrant 3, what is that going to give you? 4 pi over 3. Now watch me point to this. You want to put plus when you're going to hit that answer again. So watch, if I start here, do you see how I have to go the whole way around the circle to get there again? So it's going to be plus 2 pi n. You have to go the whole way around to land there again. And then I'm going to do the exact same thing with this answer in quadrant 4. That one's 5 pi over 3. And again, you have to travel the whole way around to get there again. So plus 2 pi n. Yeah, good. I'm going to get to that. I was looking at like which, because I know you guys are like so through with me right now. So I'm trying to choose which ones I'm going to do and which ones I'm going to skip. But yeah, I'm going to get to that. All right. So what would you do for this one? Yeah, subtract 1. And then you would want to square root. But I threw one of these on here too. You can't square root a negative, so no solution. Maybe I'll do 2 more. I think I'm going to do. I think we'll do the next 2. We'll do 10. We'll do 9 and 10. All right. So for this one, you would add 1. Actually, I made that the exact same problem, except a -1 instead of a +1. So you would add 1 and then you square root. Now, when you put a square root, you have to put plus and minus. And the square root of 1 is just 1, but you have to put the plus minus there. So that's not going to be a triangle. That's going to be a circle. You want places on the unit circle where cosine is positive or -1. So cosine is x. That would be left and right. Good. Now, this one we had to write them both separately. This one you can get away with just writing it as one answer because they're exactly halfway across the circle from each other. Do you see how these are not exactly spaced halfway across the circle from each other? It's not an even increment. This one you can though. What's the first answer? Like if you're right there, what is that? It's 0 pi. Now watch me point to this. How far do you go around to hit the next answer? Yeah, pi, and then you go another pi and you get this one, and then you go another pi and you get this one. So you can say plus pi n, and you can just write one answer instead of having to write it separately, but they have to be evenly spaced for you to do that. If it's not exactly evenly spaced, you can't get away with that. All right, we'll try one more. You would subtract 1, so that's going to be -1, and then you would divide by square root of 3. So it's going to look like this. Yeah, I think you guys can handle combining those steps. But what did I say to do? Because that's not on the unit circle. What do you have to do to make it look like something that is? Yeah, divide them by 2. So then you have your 1/2 and your square root of 3 over 2. So it's tangent and it's negative. So we need to find quadrants where tangent is negative. That won't be quadrant 1 because everything is positive there. So we need quadrants where tangent is negative. What do you think? Good. If it's not quadrant 1, it's going to be 2, and then they go across from each other. Tangent and cotangent go across from each other. That's just how I remember those ones, right? Tangent is y over x, or opposite over adjacent, however you want to say that. So this is the opposite, this is the adjacent. You just label one or the other. It doesn't matter which one. And so what's your angle across from the 1/2? It's pi over 6. So do you see how these are exactly evenly spaced halfway across the circle? Okay, so you can just put this first one and then just do plus pi n because you're only going halfway around. Then you go another pi and then you go another pi. So what's this first answer? Yeah, 5 pi over 6, and you would say plus pi n. Now don't stop listening to me for one more second because I want to explain this. There's one other way that can turn out. You either add 2 pi n, that's if you have to go the whole way around. Pi n is if you go halfway around. And there's one special case where if you have pi over 4, do you get that the pi over 4 is exactly evenly spaced like this? Do you see what I'm saying? Do you understand that pi over 3 and pi over 6 are not evenly spaced? It only is pi over 4 that's exactly in the center. It's the only one it works for. So instead, what can you add each time? Because you're not going pi amount. Perfect. So you would take pi over 4 plus pi over 2n. So that's the one special case, but usually it'll be pi or 2 pi. That's the only time it'll look